Hey everyone! Today we'll be learning more about the force of friction. To introduce the different types of friction, we're going to analyze this graph over here. So what's being shown on this graph is how the applied force affects the frictional force that is resisting the motion of an object. So the first thing that you'll notice is there are two regions on this graph, and one is this line that is consistently going up to a maximum point, and then the other region is when the frictional force drops and hovers around a small range of values. The first region where you see friction basically gradually going up as applied force increases as well is the region of static friction. This is the resistance force that has to be overcome in order for an object to start moving in the first place. So you can kind of imagine, like, if I'm pushing a heavy table, I have to gradually apply more and more force until finally I reach a breaking point where the table will start to slide across the ground. Once that table is sliding, we enter into that region of kinetic friction. Kinetic refers to something that is in motion, so the kinetic friction is a resistance force between two surfaces that are in motion. So it's really just one surface that's obviously moving on top of the other one, but just know that one thing's already moving. Notice that kinetic friction is consistently lower than static friction. That's because it is easier to keep something moving than it is to get something that is at rest to start moving. A real-life analogy might be the comparison between walking when you're already moving versus getting up from your chair in order to get somewhere. I don't know about you, but for me it's much easier for me to walk somewhere when I'm already standing and moving around than it is for me to get up from my chair in order to go somewhere. So what are the types of things that impact how strong a frictional force is? There are two main things that can affect friction. The first would be materials that are interacting with each other, and the second would be how much these objects are pressed together. Let's start with the material. In order to understand how the types of materials impact friction or the frictional force, you'll need to recall the concept from chemistry that molecules can form intermolecular attractions with each other. The strength of these attractions depend on the molecules themselves. So you know that some pairings of molecules are going to be more attracted to each other than other pairings of molecules just based off the bonds that they form with each other and their properties. The stronger that a molecular attraction between the molecules, the greater something called the coefficient of friction is going to be. The coefficient of friction is also represented by the Greek letter mu, which looks like the letter U with a little tail in front of it. As mentioned before, the value of mu depends on what two materials are interacting with each other, and the stronger the attraction between these materials, the greater the value of mu is going to be. And the greater the value of mu, obviously the greater the frictional force will be. You'll usually be given this value of mu in a table because the values for mu are very specific to the materials interacting with each other, and at least for my class, I wouldn't expect for you to memorize these values. One thing to note is that mu is dimensionless, so there's no unit attached to this number. The second thing that then impacts frictional force is how much objects under study are pressed together, which is related to the normal force. So just to recap, the normal force is the force that surfaces exert to prevent solid objects from passing through each other, and generally the bigger the normal force or the heavier the object is going to be, the greater the frictional force is going to be. If we then multiply these two values together, so mu times the normal force, then we'll be able to calculate the value for the frictional force acting on an object. So here's the equation that's used to calculate the force of friction. It's simply mu, the coefficient of friction, times the normal force. So this is it written out on top, and then on the bottom is what you'll see on your equation sheet. So force of friction is equal to mu times the normal force. So one question you might have is, how do you find the normal force? What can help you figure out the normal force is drawing a free body diagram. So let's say that you have this object and it's sitting on the ground. In this very simple, basic scenario, the ground is horizontal and this object is not on an incline. So obviously, since this object has some mass, this means that the object will be subject to the force of gravity acting on it. However, since this object is on the ground and is not accelerating upwards or downwards, it's more likely going to be moving horizontally because we're talking about sliding something across the ground. There must be a force exerted by the ground on the object that balances out or cancels out gravity. And so that would be the normal force, which is the force that again prevents solid objects from passing through each other. In this case, prevents the solid object from falling through the ground. So if we were to use this free body diagram to solve for the net force acting on an object vertically, we would simply subtract any downward forces from any upward forces. In other words, our upward force would be the normal force minus the downward force, which is the force of gravity. However, since this object is not accelerating in the vertical direction, we know that the net force of the object vertically must equal 0. So we can plug in 0, since the net force vertically is 0, into this equation up top, and we would get that 0 is equal to the normal force minus the force of gravity. But if you want to solve for the normal force, all we have to do is now add the force of gravity to both sides in order to isolate the normal force, and you'd end up with something like this, that the normal force is actually equal to the force of gravity. So this is obviously applying just to this simple scenario where we have an object on a flat surface or on the ground, a horizontal surface, no incline. If there's an incline, then you'll deal with trigonometry and have to kind of draw out your component values. But in this scenario, the normal force is simply equal to the force of gravity. And then once you know that they're equal to each other, again, for this very simple scenario, you can simply solve for the magnitude of the force of gravity by using mass times the acceleration due to gravity. And so once you know the magnitude of the force of gravity, that will be the same as the magnitude of the normal force, since they have to balance out and cancel out to give a net vertical force, or F net vertical, that's equal to 0. Now, before we practice some calculations, let's chat about the net force of an object horizontally, because that's more likely where you'll see the frictional force acting is in the horizontal direction. So to solve for the net force of an object horizontally, you'll want to subtract any leftward forces from any rightward forces. For example, in this free body diagram, F net horizontal would be F applied, because that's acting rightward, minus the force of friction, which is working against the direction of motion. It's important to note that some problems you'll hear they say you want to overcome static friction, and when you're overcoming static friction, you're basically finding the tipping point at which the object will just begin to start to move. So, in other words, at this point in time, the object is just about to change its motion from rest to motion, but it hasn't yet started to accelerate and change its motion from rest to movement. Therefore, there cannot be any acceleration at this point in time. It is just the point right before the object begins to accelerate. So the best way to capture when you're overcoming static friction is saying that F net horizontal is equal to 0. If F net horizontal is anything greater than 0, that would mean the object is already in motion and is experiencing kinetic friction, not static friction. Hope that you found this video helpful. Stay tuned for a video reviewing force of friction calculations. Until next time, always remember, this is fine, I can do it. Bye!